Hi everyone, Professor Erica here. I'm going to be doing the nitrate reduction lab today. So the nitrate reduction lab is a lab that helps us understand how bacteria can change nitrate, which is NO3, into reduced forms of it, which can be nitrite. But the main point of this lab is to find out if a bacteria has an enzyme called nitrate reductase, which allows a nitrate, NO3, to be changed into NO2, and even further down to nitrogen gas. So this is a great test for that, and I'll show you how the results are done and interpreted. So for the nitrate reduction lab, you would have inoculated E. coli. So here's E. coli. It's grown in the nitrate reduction broth, which just contains nitrate, some other nutrients, in order for act as a substrate for that enzyme nitrate reductase. And then here we have Micrococcus luteus that is grown here, and you can see as the bacteria kind of grows, it kind of sometimes settles to the bottom, as it sometimes also dies and settles to the bottom, but it's been growing in here, so you see all those little, the cloudiness or the flakiness. Here we have some Pseudomonas is also grown in this medium. And then here we have a negative control with nothing in it. So what we're going to do today is we're going to take some of this medium that your bacteria has been growing in, and we're going to put it into separate tubes here, a smaller amount, and then add our reagents. Just to make sure we keep everything straight, we have a tube. We're going to put some of this E. coli into a new tube. Okay, so we're going to label that E. coli. The next tube we're going to label Micrococcus luteus. Next tube is Pseudomonas. And then the last tube is our control with no bacteria growing in it at all. You've labeled all your tubes. You now will take this pipette, and you're going to take some of this liquid, about 2 ml of this culture grown, and put it in a separate tube. Okay, so you grab this pipette man here, and this you can move back up and down, and that will pull the liquid out of here, pull the culture. Okay, so you grab this, and you don't have to be sterile for this, because these cultures will be thrown away after today. So this entire thing, this entire pipette here will hold 2 ml of liquid. And so I'm going to put that 2 ml of liquid and just dispense it into this new tube here. Okay, and you do want to change your pipette between each of these. So I'm going to go ahead and keep doing that. Okay, so I've now added about 2 ml to each of these new tubes from the culture tubes for each of these bacteria. So something else that you'll notice about the nitrate test is there is an indication for a small indication, but there is an indication for Pseudomonas aeruginosa having these bubbles on top. I don't know if you can see that, but it has these bubbles that are formed after it grew. And that's an indication that some sort of gas was formed, and that is likely, it is the nitrogen gas that is formed. So this one should be a positive for nitrate reduction. So it took that NO3 and it reduced it until it made N2 as nitrate gas, and then it came out as little bubbles. So that's the one that you know that is positive, and we'll see the result. Now with the closer up showing these 4 tubes, E. coli, a little bit of E. coli, a little bit of Micrococcus luteus, and a little bit of Pseudomonas, and then a control tube. So I'm going to add 5 drops of reagent A, which is the sulfonilic acid, and 5 drops of reagent B, which is the alpha-naphthylamine. So we're going to add, and it's important that you add them in this order, reagent A first. So we have 1, 2, 3, 4, 5 drops of reagent A into each of these. 1, 2, 4, 5. Okay, so we added our reagent A. Then once you add your reagent A, and you're going to always want to wear gloves when you handle these reagents because this is a pretty strong acid. You don't want to get it on your arms or fingers. So you mix these a little bit. Okay. So then we will add our reagent B, 5 drops of reagent B. And you'll notice that the E. coli has already turned red. Okay, so E. coli has already turned red after adding only reagent A and B. And this means that E. coli is positive for nitrate reduction. Okay, so because of that red color. And what's happening is that reagent A went in and reacted with the NO, and reagent B, they reacted with the NO2 that was formed in this tube. Remember, there was NO3 as the substrate for the nitrate reductase enzyme, and the nitrate reductase enzymes is produced by E. coli, and what it did was it changed NO3 into NO2, and that reacted with reagent A and B and caused this red color to form. Okay. So now you'll see that all the rest are colorless. Okay, and colorless can mean a negative, or it can mean possible positive. So what we want to do now is add zinc. So here we have some zinc powder. It's very flammable, so you have to be careful in the lab. So you can't use this near a flame at all. So we're going to add zinc to the ones that we don't know if they're positive. And you can't really, I don't know if you can see it, but it's just a little powder that's released from here. You don't need very much. And then you then go ahead and mix the tubes. Okay, and so what you'll notice now is actually the Micrococcus luteus, we're going to add a little more, and the control are turning pink. So the reason why now this microluteus actually indicates after the addition of zinc that we have a color, a pink color, or red or pinkish color, because Micrococcus luteus is negative for nitrate reductase. So what happens when you add zinc? So zinc actually allows NO2 to be formed from the NO3. And that way now reagent A and B will cause a red color, but only after the addition of zinc. And that means that there was still NO3 in this tube because Micrococcus luteus did not have the enzyme to change NO3 into NO2. Okay, so Pseudomonas remains colorless. The reason why is because there's no NO2 in this tube. Even though there is no NO2, doesn't mean that this is not a positive result. This is just saying that Pseudomonas takes NO3 and really reduces it from all the way to nitrogen gas. Whereas E. coli, it just stopped at the first step, NO3 into NO2, using its enzyme nitrate reductase. Okay, so this is positive for nitrate reductase, and this is also positive for nitrate reductase. However, these, the control, right, is pink, and this one is pink because the zinc reacted with A and B, and the available nitrate NO3 was turned into NO2, and then it reacted with the A and B using zinc, however. Okay, so that's the nitrate reduction lab 5-8.